And press the button. Okay. Hello, everyone. My name is Vladimir, and I'm happy to say that we're back with the interview series on the Architecture Weekly YouTube channel. And today, Marharita Nedzelska decided to join us and speak about static code analysis. She's a software engineer at Sonar and Kotlin GDE, Kotlin Google Developer Expert. Welcome, Marharita.
Yeah, thank you. Thank you for this introduction. Just, I think, did the same mistake. The company is called not Sonar Sonar is our product.
Okay.
And the company is Sonar Source, or just simply Sonar.
Oh, simply Sonar. Okay. I'm sorry for that, but I will take a note for the future. Okay, so how are you doing today?
I'm fine, thanks.
Good, good. Can you please describe, like, shortly who you are, what are you exactly doing at Sonar, and how you ended up as a Kotlin GDE?
So at Sonar, I work as a software engineer and take some technical leadership role in our Kotlin analyzer and Java analyzer, and actually a GVM part of Sonar Source. Static code analyzers part. So I'm not in charge of Sonar Sonar Cloud. We just integrate with them, collaborate with them. But my main focus is writing roles, writing features, and implementing static code analysis. And about GDE, it happened a long time ago, I think in 2020, when they just launched this Kotlin category, because previously you could be Google Developer Expert in any other area like web, Angular, I guess, Dart, Flutter, whatever. Like there are a lot of products coming from Google, and you can be Google Developer Expert there. And then one day they decided, why do we don't have Kotlin there? They opened Kotlin category, and a few people from different parts of Google JetBrains messaged me on Twitter and say, like, we have this opportunity now, and we think that you are a good fit. So just apply. So it took me a few months to apply because I was in the middle of my relocation, moving jobs. And then when I finally started the process, it went pretty smoothly, quickly. I had a couple of interviews, and then the decision was made, and they gave me this title. Now I'm a GDE.
Yeah, cool. Congratulations. I believe the process is a little bit cumbersome because you need to include a lot of articles, public talks, and so on. You need to mention the impacts, like how many people attended a particular talk, and so on and so on.
Yeah. Feels like, for example, for Java champions, as far as I know, the process is much easier for people. Like, you don't actually apply. It just other people can either notice you or not. And here you need to apply, and you need to reflect on what you did in the past, how was the impact. And yeah, it takes some time. So that's why maybe some people who deserve this haven't actually applied yet, because they need to step back and write this application.
Okay, good. Let's start with some introductory questions. So, like, how would you define static code analysis for someone who is not familiar with the concept at all?
So to me, when I actually talk about static code analysis at some conferences and my talks, I usually present it as a, so, in math, we have function from X to Y. So technically, it's a function or a process that takes your source code as an input and gives you some inspections, report results as an output. So simple words, we just take your source code, and then we try to send you a report to explain what could be changed, what is not nice there, maybe some code smells, maybe security issues. And in simple words, this is what static code analysis is about.
So finding the problems in the code that's not so easy to detect with the human eye.
Yeah, sort of. like this. And one of the biggest main points is that we only have a source code and maybe a little bit of additional information, but we don't execute it. This is the difference between static and dynamic. We do it statically. We can just read what you have, but we are not executing your code. And detecting some issues while you're executing, it's more of a dynamic part. And Sonar, we are not doing this.
Okay. But how does static code analysis thing work? So does it operate with just the text, or does it build a model of the program in itself? How it happens?
Actually, it's you can do whatever you want. So I know there are some tools that can just read your code and do regular expressions and find some patterns. And if I'm not mistaken, I think Promise and maybe some early versions of older analyzers are doing this. But that's not optimal, because once you want something more advanced, it's pretty hard to operate just with strings. So we are usually operating with a structure called syntax tree. And if you know a little bit about compilers, compilers are usually divided into two parts, front end and back end. And front end, it's transforming your source code into some intermediate representation, and in our case, it's a syntax tree. And the backend is taking the syntax tree and transforming it into some binary representation. It could be bytecode for Java. It could be just bytes, machine code, whatever, to be able to execute it. So for us, we don't care about backend part because we don't need it, but we care about front end. So technically, we need to somehow have this front end to transform our source code into some representation, in our case, a syntax tree or abstract syntax tree. And so your code basically looks like a tree. You have the root node, it could be file. In this file, you can have, for example, classes, or if your language supports it, you can have top-level declarations or top-level functions. And inside your classes, you can have properties or fields or functions. Inside your functions, you can have statements, and your statements can consist of different expressions, whatever. So this all is a tree. And looks like it's pretty easy to operate with this tree, and we can build inspections on top of this. So, for example, one of the simplest rules that usually we can implement is that this function cannot be called in this scope. So you need to find to locate this function, somehow search in the tree, and then you can report an issue on this function.
Okay, so you're actually using a compiler's front end to build this tree for you, or you're implementing your own version?
It depends. It's a very good question, because sometimes if usually we are writing things in Java, and not in all languages you have compiler written in Java and then something JVM based. So we have to implement things on ourselves. For example, for Python, I think we're implementing our own front end. For JavaScript, it initially was our own front end, and we moved to a third-party one. And COBOL, T-SQL, PL/SQL. And even for Java, we also had our own front end for some time. But then we realized that it's extremely hard to maintain, because, of course, languages evolve, and we need to adapt our syntax trees. For example, in Java, what are the recent changes? Pattern matching on switch, which is extremely hard to implement. And that's much easier to take already existing front end. That's why in languages like Java, like C#, like C++, and Kotlin, and a few other languages, we are using an external front end. So we are actually depending on some existing compiler to transform the source code into syntax tree, and then we are writing the rules on top of this syntax tree. So in Sonar, for different languages, we have different approaches. But if this language is more or less popular and you want some advanced checks, it's much easier to depend on something more not maintained by us.
Okay. And if it's not popular, there's little sense to make the static code analysis for it in the first place, right?
It depends on what do you mean like popular. Because on the one hand, like you can say COBOL is not popular. On the other hand, it brings us some like customers and they're using it and they're happy. So why not?
Yeah, I remember several years ago, there was a rumor about the project in Canada that some bank or oil company was upgrading the software from COBOL to new COBOL. So yeah, it's still there. So yeah, I bet it still required the static code analysis. But when we're talking about that, like what types of issues or bugs can static code analysis find?
Like as much as possible. What do you mean by like by types? Like bugs, vulnerabilities, what?
Well, I mean, we can go from very easy ones like typos, like using the wrong variable, like you're assigning like x to width and y to width, not height, for example, right? So this is just typo or like using the wrong variable, right? To some advanced bugs with concurrency issues, threading issues, and so on.
So I think it's an interesting question. So it depends. Like static analysis, it's still it's some precision. So you cannot like have an ideal static code analyzer because you probably heard about halting problem. That technically it's unsolvable problem to say whether the program terminates or no. So, and static code analysis is about this. So we can detect like simple and maybe not so simple things, but we will always have some false positives, false negatives, and the more advanced rule is, the more like advanced feature is, the harder it is to make it very precise. Like for example, some time ago we wanted to implement a rule. It was in Kotlin that in suspend functions you don't use blocking code, and if you use it, you need to use another dispatcher. So, which is like pretty obvious. And then the question that we asked ourselves, and we still have no answer: how do we know that this function is blocking or non-blocking? Because okay, we all know that thread sleep blocks the thread. We all know that communicating with database, some like network, if it's synchronous, it blocks the thread. And then if it's just some long computation, technically it blocks the thread, that it's like doing some job. And then it's like question, what is the definition of blocking function? What if it's like IO operation, but it's extremely fast, so we don't care? And then we had to come up with some heuristics. And then if you come up with some heuristics, you like say that, okay, I cannot understand whether it's blocking or non-blocking. I can just try to come as close as possible in this understanding. But that means that we'll definitely have some false positives and false negatives, because we still need human to detect, to investigate this. And in static analysis, we don't have this opportunity.
Yeah, does it come down to the basically question for the developer, like is the function that you're calling is blocking or not? Because from what I remember about Kotlin, the suspend keyword was specifically introduced to let the developers indicate for the compiler that actually this is a function that could block. So
yes, and like if we're talking about pure Kotlin, we can assume that everything that is suspend is not blocking, it's suspending, and everything that is not suspend, it's like blocking. But then like you can have just stupid simple function, I don't know, just returns true. You should not write suspend on it because it's not supposed to take much time. And however, can you say that it's blocking or non-blocking? So I think it's we still don't have a proper answer. I think we came up with some heuristic that, okay, if the function throws some IO exceptions or what else? Okay, I don't remember exactly, but it's still like inside their code, there are some functions that we know that they're well-known blocking ones, or they're using some API that we know that they're blocking. We assume that this function is blocking, but we still like cannot say because it's a borderline. And this concept of blocking and suspending is sort of a still for human understanding. Because if your function is just executing long and you don't want to block the thread, so you say that should be suspend function, but still maybe it's not what you wanted to do.
Yeah,
so it was still a tough topic. Yeah,
it is. Like in those situations, I always want to speculate. Like when you have those borderline things, I always wonder, can we employ machine learning for that? And trying to teach the machine and saying like, hey, those functions are blocking, those are not. So please help us to understand about those other functions. Do you have any plans to like employing some machine learning capabilities in the static code compiler analysis?
Actually, we were thinking about this, not in this case about blocking and suspending, because apparently, like from user feedback, we haven't get anything. So I think almost no complaints about those rules. So probably it works well. And but there was one rule where we definitely wanted to implement machine learning, and maybe we'll do it somewhere in the future. It's about commented out code rule. So we have a rule in different languages that if you comment out some piece of code, I say like, okay, you commented out some piece of code, maybe you don't want to do it, maybe you did it accidentally, or maybe you don't need this part, so remove it. And the rule is nice. There was a problem with this in Kotlin. A long time ago, we rewrote our Kotlin analyzer because previously it was very stupid simple, and it was not possible to extend it when we wanted to add some advanced features. So we completely rewrote the analyzer, and we added the semantic information. And in order to have semantic information, we need to use compiler frontend to actually try to compile our code. And it takes some time. And this is just a precondition. So what was the real problem? In the rule, how it worked previously, we took all the comments and we tried to compile, to parse them, just parse without compilation. And if parsing was successful, we say, okay, parsing was successful, so this is a code. Or parsing was not successful, we assume that it's not a code, so we are fine. And that's how we decided whether to report an issue or not to report an issue. But what happened? When we added semantic information, we started not just parsing, but also compiling code. And of course, it takes much more time. So if in your file you have 100 comments, we will try to compile each comment. So it's like 100 times more compilation than it was before. And it was a huge performance degradation. And then we had to understand what to do. And we a little bit rethought this rule at all. So we implemented some heuristic. We tried to find some common constructions in the code in order to not involve compiler, or only involve compiler in like very end, where we're like almost sure that this is a code, but we want to double check. And this allowed us to improve the rule. But however, a few maybe weeks ago, months ago, our maybe R&D team. We have actually R&D team in our company that takes care of all these innovations of tries to apply machine learning or find some security vulnerabilities. And they reached to us and say that we want to try to implement this rule with machine learning. So Can you give us a hint how to do it, how to test it, just to understand how it works? And there are some experiments. So maybe in the future, we'll rewrite this rule completely with machine learning.
Yeah, that's promising. Hope it won't take too long to try it out. Okay. Can you please describe in more details, like you mentioned these false negatives, false positives. What does it mean exactly?
Yeah, as I told you previously, it's very hard to implement very precise rule. So in most cases, we need to cut some branches and make some precision. And it means that in some cases, we raise an issue where there is no issue. It means the situation is called false positive. Or we don't raise an issue when there is actually an issue, and this situation is called false negatives. Usually, we don't care much about false negatives. We care more about false positives because they are annoying and they discourage people from using our products. So in our case, false positives are much more painful, and that's why we try to avoid them. And every time people face them, they report them somewhere on the community or maybe to our paid support, and we try to fix them all the time. How this happens? That's a good point. Maybe what could be a nice example? Yeah, maybe let's just start from one stupid simple rule. We have a rule that says that your import is unused, remove it. Some compilers actually provide it as a compiler diagnostic. In Kotlin, we don't have this compiler diagnostic, but whatever. This import is unused. How would you implement it in this like very simple, stupid solution? You just try to search for this, for the end of the import, for this exact name, and search for usages in the code. If in this file you can find these usages, means that this import is used, so we don't report an issue. If we don't find, then we should report an issue because your import is not used. This works, and then, for example, some next day after release, a customer comes and say, I am using this function, but this function is saying me that this is unused. Why it happens? So this is, we have a look there and we see that this definitely is a false positive because, okay, if you navigate an IDE, you can definitely see that this function is used. For example, it's Kotlin. What happened? In Kotlin, you can write operators. You can overload operators. And if you overloaded it somewhere in a different place and you want to import, you import it, for example, with the name of this operator, like plus, minus, assign, equal, whatever. And you are importing this name. But in the code, you're not using this name. In the code, you're using actual symbol. It's plus, minus. And of course, our previous algorithm doesn't work. So this how this false positive occurs when the algorithm that you implemented cannot cover all the cases. So this is a situation when we have a false positive, and then we confirm that it's a false positive and we have to fix it. So we add additional branch for operators to understand that this usage of the operator is actually a plus or minus, so we can map it properly to the importable name. And small cases like this, small things like this happen all the time. And the more features your language proposes, the more syntax sugar there is in your language, the more such corner cases we have.
Okay. So basically, false positive is when you report a problem that doesn't exist. A false negative is when you don't report a problem which does exist.
Yes, exactly.
Okay. Yeah. I believe it's very annoying when you're like when you don't have a problem and compiler says like, or static code analysis tool says like you screwed up here. No, I didn't. So yeah, that might be.
Yeah, exactly. And that's why we are like looking for this feedback. So people, if you see that there are some false positives, don't hesitate to report it to us and we will fix it.
Okay. What's easier for you as a static code analysis developer to work with? Like, I mean, dynamic languages like JavaScript, or static type language like Kotlin or Java or anything else?
I think it still depends on the language itself, but I feel like statically typed language are a little bit easier, because you have like strict rules, what can happen, what cannot happen. But I think it's more about like development in the language. I prefer statically typed language. And like one of the recent things that I faced in Groovy, that somebody in their Groovy, let's say in their configuration for Gradle written in Groovy, in the place where string was expected, wrote a file. And nothing prevents you from doing this in Groovy. However, on our side, we are writing in Java or in Kotlin, and the API expects string, and then we have like sort of a API mismatch, because technically you expect for string and you operate with an object like it's string, but because somebody you was using Groovy and used dynamically typed language, they didn't care, and that's why we screwed up. And we have to adapt to it and keep in mind that, okay, somebody could use Groovy for this, and we cannot just simply accept that it should be string. It can be anything, actually. And things like this annoy me, so I definitely not a big fan of dynamically typed languages. But from the perspective of writing rules, I think we don't care much. It all depends on the language. If language is nicely designed, then it's not a big deal to implement any rules. So the patterns are still the same. And maybe some rules are a little bit more difficult to implement for Kotlin than for Java, just because in Kotlin we have a lot of syntax sugar and a lot of features that we didn't have in Java. And you have to keep in mind like all this delegates, overloading, and just things that complicates our life. And it has nothing to do with this language being static or dynamic. It's just about the features.
Okay. So the more complex the language is, the more difficult it is to prepare with the static code analysis there. Okay, we'll keep saying static. Let's discuss the difference between the approaches of static code analysis and dynamic code analysis, and what are the things that dynamics can do and static analysis cannot.
Honestly, like I never worked on dynamic code analysis, so I only like read about it and know as a like general knowledge. So I cannot say much about that. The biggest difference that in static code analysis, we are not executing the code, and in dynamic, you're actually trying to find something on the fly. So it could be, for example, you have your production system and you can monitor on the fly what happens. So you have, you know exactly what is the type of something, what's exact value, and you can find some stuff there. And in static code analysis, we cannot know this because we're not executing code. We don't know what are the inputs. We can only try to build sort of a graphs or of possible solutions, of possible flows where things could go.
Okay. Well, is it enough to use only static code analysis for the proper quality assurance, or both tools are required?
I think it depends on what you want to detect. So I'm not sure. Like I think it's okay to use just static analysis. It's just the more tools you use, the more things you can detect, the more safe you are, because you can detect more things. But the problem is it's still hard, even if you have like millions of tools, they report something. Even after you fix everything, we still cannot say if your code's safe or not. because there could be some vulnerabilities that just wasn't discovered yet, or there could be some code smell, but we don't have a rule, or it was a false positive, false negative. So we try to do as as good as possible. So we try to implement things as close as possible, but we still there still could be some blind spots. So to my taste, if you want to feel safe, the more tools you have, the more metrics you have, the better. But yeah, you need to have some sort of a balance, because sometimes if you have too many tools, they can discover a lot of issues. Then you need to fix them, and you spend time fixing them. And maybe sometimes you don't care in your case. So you need to sort of find the balance.
Okay, thank you very much. Let's talk about the static code analysis for security, because we touched only, technical or typos or missing imports things. But security is important, because in code you can do a lot of make a lot of problems there. I don't know, writing the private data to logs, or exposing the vulnerabilities, like SQL injections. Always C, C++, there's plenty of mistakes that could lead to the remote code execution, right? So how static code analysis can help with the security issues?
It's a good point. We can help on different stages. For example, I think one of the recent features in Sonar, we start trying to detect leaked secrets. For example, if you accidentally put some secrets or passwords or whatever. So if we see that these things are hard-coded, we try to react as soon as possible. So you can find it early in the IDE before pushing to your repository. And this is one point. So we can technically just scan your code and find some issues that are on the surface. And another thing that we also have a security engine, which is symbolic execution with sort of a security context. So we can try to detect issues like SQL injections and other vulnerabilities. So I think it's very similar to what we can do with static code analysis, but we can just use it for security purposes. And if we are talking maybe more closely about security analyzer, just one small disclaimer, I'm not a deep expert there, because I'm not very security expert and I'm not working on this analyzer, but that's what I know about them. They're using some intermediate representation for different languages. So we try to the engine is unified for Java, for C#, for Python, I guess, for JavaScript, if I'm not mistaken. So it's the same engine. And the most important part there, that we can find issues somewhere on the border. So we take into account your, for example, XML configuration, some other properties. It's not just about the code. It's in comparison when we are talking about static code analysis for code quality. Usually we are talking about a single file. And if we are talking about security, there are a lot of other things that are taking part in the analysis, like your configuration, like what dependencies were used. And so you can follow the flow and understand how it can actually lead to some vulnerability, and how SQL injection can happen here or there.
Okay, so from the security perspective, you're not considering just a class or a file, but you're trying to build a model of a program in general and see what it depends on, how it's configured, something like that.
In simple words, yes. So we were not just building this abstract syntax tree, we are actually building control flow graph.
Okay.
To understand where it's going, what is an input, what is an output, and what is actually exposed, what is not exposed.
Okay, so the analyzer is capable to understand that like this class is speaking to the database, is using those credentials, right? They're coming from this config and so on.
Yeah, so some sort of this. Of course, like not everything, because there are a lot of different frameworks, different approaches. But I think the most common ones we try to detect and try to always improve.
Okay. Let's discuss the process and team things. So at what stage in the development process should static code analysis be introduced?
It's a good point. I think it depends. In our company, we try to do it we try to promote doing it on different stages, like on all the stages. For example, we have a plugin for IDE called Sonar and Kotlin. So it has nothing to do with your manager or whoever. Just simple developer installs it in their IDE, and then when developer is typing, we try to highlight some issues before they were actually committed, go to an EPR or to production. So there you can find them as early as possible. This is one stage. The second stage is when you have a pull request, for example, or merge request or whatever. So you have some sort of a code review or your repository. We try to promote also pull request decoration. So while you haven't yet merged things to master, but we already can report the issues on your changed code, what you changed and what could be problems there. So in this stage, it's also important to see it before merging to master. Another stage is when after you merged things to master, we also do the analysis, like people usually also do the analysis, and you can see what actually changed in your whole code. And maybe there were some issues that were not, couldn't be seen in the pull request, but appeared in master. This could happen in two ways. For example, you deprecated something and then it affected some old code. So you haven't seen this issue in the pull request, but you will see it in the main code. And another, if you are not always on the top of your master, somebody could already put their code in the master and your code might affect this. So when you merge, it's also important to see what changed because issue might be different. And and then of course, from time to time, it's important to have all these dashboards to have a look what's the state of your projects, what are their ratings towards security, quality, maintainability, to see if you have some problems where maybe you need to schedule some sprint to improve the code quality or remove the technical debt. So my answer would be you can introduce static code analysis in almost all the stages, in almost from all different perspectives. The earlier you do it, the lower the technical debt and the less amount of time you will spend afterwards to fix things. And so it's more about what you want to achieve.
Okay, thank you very much. What about the help with the architecture aspect of the software? So can static code analysis detect that, for example, we suddenly introduce the circle dependencies between modules, for example, or we have business logic in the module where it is not supposed to be, or in the layer, and so on? Can a tool like Sonar do this?
At the moment, we try to look into this direction. We don't have things for this yet, but we are definitely looking there, and we are thinking about the rules to detect things like this. And yes, this is possible to some extent, because it still depends what you think about, whether it's a circle dependency in terms of modules, packages, or class, or even simple files. And they are also discussing this point, and there are already tools on the market that can do this. For example, I think it's a Sonar graph tool that can actually show you some architecture metrics about your code and maybe show you how you can split to get rid of some Silk Road dependencies and like which edges you can remove. So you don't have Silk Road dependencies anymore. And I think this is something where we should grow and come in the future. As recently we were splitting one of our projects in the modules, and we found out that despite we tried to promote their clean architecture, we still made a couple of mistakes where we had to somehow get rid of modular dependency. Because when it was all in one module, it was extremely hard to like keep eye on this, and we accidentally introduced something circular. And then when we tried to split it into modules, we could not do this because we have this problem. So the point is, if you have it already in the modules, it's too late. Maybe we should do it earlier in the scope of packages.
Yeah, that's a classical problem of migrating into modules. Yeah, you suddenly see that there are more interdependencies than you intended, and you're screwed. So yeah. Okay, my next question is like how the team can effectively address the issues that that are shown by the static code analyzer, because this is especially a problem when you, for example, joining the team, you're looking at their Sonar dashboard, and it's like all very bad, like it's all red, like a year of technical debt inside. Like, how would you tackle that?
Yeah, and that's why, like in Sonar, we propose a solution called Clean as You Code. Because yeah, it's extremely hard to see if you look at your technical debt on your overall code, and it's like years or thousands of years. You're like, okay, I'm not going to do it. So the goal of Clean as You Code is to focus on main code. On new code. There were some studies that every year people, like if you're working on a project, you're rewriting like 60 or according to different vendors, it's either 60 or 80 or 50% of the code. But the point is that you touch some part of the code and you rewrite it. So if you adopt this Clean as You Code, it means that, okay, you touched something, and then we showed you, okay, there are new issues. So you can clean all the issues in this one file that you touched. And then with the next commit, you touch some of your other files, you will clean those files. And then it means that eventually you clean up all the issues in the most like important part of your code because you touch it very often. There still would be some like old issues on the overall code, on the code that you haven't touched for some time. For addressing this, you can schedule some sprints. You can maybe do some gamification. If you like fixed, I don't know, 100 issues, you can eat a cake or go for some team building, whatever. So it's up to your after your fantasy. So the thing is, you can somehow gamify it. But if you adopt this Clean as You Code, you will easily deal with new code. So the main point that focus on fixing issues in new code, and eventually you will like and stop introducing new issues. So eventually, if you won't have issues in new code, the biggest problem would be only just old code. And in old code, you can maybe schedule some pain technical debt from time to time, and you will keep your project clean enough.
That's a nice strategy. However, the cake is not the healthiest option for a reward, but yeah, still worth using. Okay, thanks. We have a question in the chat. Like, when languages release new features, do you prepare to support them in advance before they are released? Like, I don't know, the language proposals, for the Go, I think there was a proposal for the generics, for example, right? Like, have you prepared it in the analysis in advance?
That's a good question. Like in ideal world, I'd prefer to do this. So we know where language goes, we know what should be the new features. and we will try to adopt our rules, our code base to prepare for these features. However, in practice, it's not usually like this, because we have, of course, limited amount of resources like people and a huge amount of different languages, so we have to prioritize. And that's one point. Another point, for example, for languages where we use third-party compilers, we actually depend on them to support this feature. And there was some problem with our Java compiler because there was a bug that affected us and we could not introduce the support of new feature. So in this case, we could either contribute to fix this issue on their side, fork, or like help them to fix the issue, because we are dependent on them, and unless they fix it, we cannot update. So this it depends, but I think that's the best option would be if we try to prepare ourselves in advance. However, currently we are not doing this. Currently we try to keep up, and as soon as things are released, we try to support these features.
Okay. Do you have any priorities between the languages? Like, for example, like Java is the main, and like Kotlin is second, then TypeScript, Go, Python, and so on. Or you have like even distribution among the languages?
Of course, like not all languages are equal, because definitely you know that some languages have more adoption, some have less adoption, and we have customers using this or that language, and this influences definitely our priorities. So, for example, maybe the main point is that if language is of a high importance, we have a dedicated team for this. So we have a dedicated team for Java, for C++, for JavaScript, for Python, for .NET. So these sort of languages are of main high priority, and we try to be more focused on those ones. Languages like Go, like Kotlin, Ruby, Scala, they're sort of secondary priorities. So we work on them when we have time or when there is really nice, like important feature. But of course, if there is some work needed for Java and some work needed for Kotlin, we prioritize Java more over Kotlin. And it's not because we don't want to or because we don't like believe in the language. It's more that we have limited resources, and we have to prioritize. If we had like, hundreds or thousands of people in our team, I think we'll definitely prioritize every language and be happy to have like first-class support of every language. However, it's not the case, so we need to decide what to work on.
Okay. Do you have any support for like pure functional languages like Haskell or Elixir?
No, not yet. If you want, I think on our community, you can the proposal. So if from our company management product perspective, we see that there is something, maybe we'll put it on the table. At the moment, I don't think like true functional languages are really important for us, just because this market is not really huge.
Yeah. Okay. Let's talk about the team picking up the static analysis tool. Like, what should be the decision tree for a team picking up on such a tool? Like, how do you consider like what features are absolutely necessary in this tool? Like, what is the biggest benefit that should be brought to the team, and so on?
It's a good question, but I think it would be unfair to ask this question to me, because definitely I would promote the product that I'm working for. If we just forget about this and try to be more like I'm a technical lead or like engineering manager and we want to pick up some tool to maybe the first question that you need to ask yourself is like, what are we trying to achieve? What is our domain there? And what do we expect from static code analysis? And if we expect some, very deeply into code quality, and some languages you can find over the internet different benchmarks and see how different analyzers work on different benchmarks, maybe what is the ratings, and then decide. For example, if for you like reliability, maintainability is more important over security, you go for tool A. If security is more important and you don't care about code quality, you choose tool B. So if you need both, you may want to choose tool C, or maybe you want to choose tool A and tool B. So it depends, because like it's depends on what you want to achieve and what you expect, and it also depends on your domain. Because, for example, if you're doing some like very say hard computations, or if you're working in a healthcare or in like I don't know, some software aircraft where the cost of mistakes is very high, you will probably have one sort of requirements. But if you're working on sort of, I don't know, social network, maybe you have different requirements. So
yeah,
for the first step, I definitely like just write down all your requirements, and then we'll do a research, look at the benchmarks, and then make a decision.
Okay. Yeah, I believe, for example, banking parts will require both code quality and security at the same time, because you need to be precise on money and make sure like the money doesn't go to some scammer. Yeah. Okay. The next question is about the product parts, I would say, because for, I don't know, for a social network or for some software as a service, it is usually pretty easy to understand, like the behavior, like relatively easy to understand the behavior of the users, right? So you have online analytics, you know how to proceed with that, how to get the business insight, and so on. But how do you understand for a static code tool is your product is like working properly from the business perspective?
Yeah, it's also interesting question. I think we also have like products like Sonar Cube, Sonar Cloud, and we can have metrics there. So we have telemetry, and we can see how user behave with them. And another point that we have support, we have community forum, so we can track the health of the project there. And it's very funny to see, like, once you release the new version of Analyzer, it got deployed on Sonar Cloud. The next day, if you screwed up or introduced some bug, you'll already see a lot of people reporting this issue. Like, for example, if it's for Java, because there are a lot of people using this, so we can easily react and do it. And that's the point if you're talking about more how analyzers perform. So we can be more rely on the community and support input. But if we are talking about general like business, I think it's nothing different than any other products. So for if you want to do some experiment on how whether people adopt this or that UI, we can have the same A/B testing. We can have the same telemetry to see how people behave with our product on Sonar Cloud or Sonar Cube. So I think there is no difference between like our products and any other web service.
Okay, thanks. Do you have an example of the most, the weirdest or the most crazy problem that your customer experienced and how you solved that?
The most crazy, I think maybe no. So that's hard to say what they mean by crazy. The most things that drive me crazy when I'm answering community threads, it's this misunderstanding with the people. So, for example, there was one person who is like saying, I have a problem here. And I was like, as usually, okay, I would love to solve your problem, but I cannot reproduce it. Can you please send me a simple reproducer or a piece of code that triggered this problem or like anything? And then we cannot send you the code because it's private, top secret. We cannot send you logs because it's private, top secret. And I can only explain you what I see in the logs. So that's like, okay, but I'm not a magician. Like I need something to investigate. So there are the biggest difficulties for me because we need to somehow remotely debug the problem of a user, and we are blind because usually they are very like don't want to share with us their code or the stuff, and they can understand them because it's like we have similar problems when we have problems with our like software, and we or other software that we use, we cannot disclose our code, which is private or secure. So I can understand them, but it makes our lives harder because it's extremely hard for me to investigate things. And maybe one of the interesting thing that happened to me, it happened recently on Kotlin. We introduced one rule, and for this rule, we needed to like visit type aliases and the cover and yeah, we needed to visit actually type aliases for this. And it was fine. And then one user reported that they have Stack Overflow issue. And when I looked into the code and I realized, okay, this function is not written optimal. So there should be tail recursion, but it's not written in tail recursion. That's why we don't have tail recursion optimization. So let's rewrite it. And I rewrote this function in tail recursion without any because this person wasn't able to provide me any reproducer. And I was like, okay, I will try to blindly fix it. And to me, that was the problem. I didn't have any, of course, Stack Overflow problem anymore. I was pretty happy, and I was about to like release this fix. And then I was like thinking, asking for more information from the user. And eventually he sent me this the file where the problem was. So we sort of find out in which file the problem was. So I was able to investigate it. I took this file, executed my code, and I received out of memory. I was like, oh, then I rolled back to previous code and I received Stack Overflow. And then because I wrote things with tail recursion, now I have out of memory. And I had to sort of bisect, remove some lines from the code to understand where the problem is. And the problem was in some recursive generic. And because of this recursive generic, I have sort of infinite cycle. And if we are talking about non-tail recursive optimization, just the recursion, it was Stack Overflow. And when I rewrote it in tail recursion, it was still infinite. So it was out of memory. And then, okay, I cannot release this because it's not fixing anything. And I had to find out where the problem is. And I found that the problem was in the recursive generic, and fixed it, and then fixed an issue. And the point is that if I gave up after my first attempt, like I would never fix the issue. But sometimes, like if you have sort of a third feeling that something is fishy here, maybe I'm not fixing the issue right. I still need some reproducer. So I need to annoy the user as much as possible. So user provides me a reproducer, and then I can fix it. So this is like one of the biggest problems, to ask user for the proper reproducer. And once you have it, then it's easy to fix.
Yeah, that's for their best interest, right? To give you as much information as possible. Yeah, I like the stories about like with several layers of problem that you need to really dive into the thing. Yeah, cool. Thank you very much. So I have a couple of more questions. So one of those is how do you see like the future of the static code analysis, and what are the current trends that we're observing?
I think the future it depends. I think it still goes in a different direction that we already talked about. So I would love to have more advanced bug detection, like not just simple rules in this using just AST, but also rules on the control flow graph, like symbolic execution, or so this is one direction to go more advanced. Another direction is architecture that we also discussed with you, that it would be nice to detect some Silk Road dependencies between packages, modules, or maybe wrongly designed solutions, or like, all this anti-patterns, like big class doing everything, breaking single responsibilities. So the things more they're less about the code in like this stupid simple issue in this exact line. It's more about the way how you write the code. So I would love to go in that direction, but much deeper. And another point, with the rise of AI, I think it would be nice to integrate AI in static code analysis, because it could help us, and maybe it could help us solve the problems that currently we can only solve with human eye. But I cannot say exactly, because it's just raising right now. So we are sort of living in the era where AI is evolving. But I would be curious to see how it affects static analysis.
Okay, thank you. Last question from my side would be like, what is the most interesting or surprising thing that you have learned working on the static code analysis?
I think maybe the most surprising part that initially, before I joined Sonar, when I just used Sonar products, looked at them, I thought that people who are writing static code analysis should be like gods, like they're operating with code that should be extremely smart, like 10 times, 100 times smarter than I am, because they are writing like rules on, and they are influencing how I should write my code. And then when I joined Sonar, I realized, like, I'm not saying they're not smart, I'm just saying they are ordinary people. They're the same developers, they do the same mistakes as we do. So that's okay. And on the one hand, it was like ruining some idol for me, because okay, they're just ordinary people and they also can make mistakes. However, it means, like, if you want to try static analysis, if you want to try to work and apply for Sonar, it opens the door for you, because we are not just hiring gods, we are hiring normal people, and normal people can also do static analysis. So it's not like rocket science, it's feasible.
Okay, that's insightful. Thank you very much. Do you want to share anything else with our listeners?
Maybe one last thing that we talked a lot about last time. We in order to understand how our products work, we use a lot of community forum and user feedback. So we need your feedback. If you feel like something is fishy with Sonar, you can just blame Sonar silently somewhere while writing code. But the more important and impactful it would be if you go to our community forum, write a thread and say that, okay, this is the false positive, or I have an idea, or I think its rule is not behaving properly in this context, and we'll answer you, we react. So and it will help us to make tools better, and it will help us to be less annoying for you. So this is one thing. And another thing that I wanted to share is I work at Sonar, live in Switzerland, but I'm Ukrainian. So of course, stand with Ukraine, support Ukraine. Because like, if we don't support Ukraine, if Ukraine won't won, I think we don't actually, it doesn't really matter whether we have static analysis or no, because it will just screw up the whole world and will have much bigger problems than like unused imports.
Yeah, thank you very much for that. I totally agree. Yeah, and let's hope for the best. Thank you very much for joining me today. That was a very insightful talk, and hope it will be very useful for our listeners. Well, thanks again, and have a nice day.
Thank you for having me, and have a nice day too.
See ya. Bye.